So we got another cylinder here, so we're still going to be using pi r squared times the height. So I'm still going to keep pi until I go to round whenever it gets to the nearest whole number, but next I need the radius. Remember, radius is the distance from the center of the circle to the edge of the circle. I don't need to do anything with that number yet because the radius is 7 for this problem. So sometimes you'll cut it in half because they'll give you the diameter. Sometimes they're going to give you the radius. Just pay attention to what they gave you. I do need to multiply by the height, which is the distance between the circles. So that does not mean how tall this thing is going vertically. That is not the definition of height. Height is how far this circle is from this circle. So we can see that it has a 5 centimeter height. In terms of pi, means combine every number that's not pi and then just write pi at the end. So basically say, yeah, we need to multiply by this horrible decimal, but I'm just putting it off for now. If I do 7 squared times 5, 49 times 5, I get 245. So when I write my answer, I'm going to say it's 245 times pi. And this is volume, so cubic units. Then I'm going to pick up my calculator and actually hit times pi, not times 3.14. This is saying 769.7-ish. So if I round to the nearest whole number, it rounds up to 770. So the number 3. It's also a cylinder. It's a little crooked, but it's still a cylinder. So I'm still going to use pi times r squared times the height. R is the radius, which is the distance from the center of the circle to the edge of the circle. They gave it to us this time. We'll square that number times the height. Now this is where it's kind of weird, but pretend that this is a building. The top floor of this building is where you are standing, and it's a circle on the top floor. The bottom floor is also a circle. So we need the distance between the circles, which would mean you take a ball and you drop it from the top floor. How far did it go until it hit the bottom floor? Now the bottom floor is technically not right below you, but you'd still say it hit the ground if it hit here instead of hitting in the circle. So I need that distance to hit the ground. We can see that it's 15. So in terms of pi, means I'm going to take 5 squared times 15. If I type it in correctly, I see 375. I still need to multiply by pi, so if it says in terms of pi, you cannot just write this. That's wrong. We did not get that whole number. We need to say that number needs to be eventually multiplied by pi. So pay attention to what you're actually saying your answer is. Then get the decimal by multiplying by the actual pi button on your calculator. This time I got 1178.1-ish. So nearest whole number is just 1178. And then using that figure, what is the area of a horizontal cross-section? We talked cross-sections in lesson 1. This would be, I wish I could make this slanted cylinder shape out of Play-Doh. If you did, and you chopped it horizontally, meaning you took your knife and you cut it here, you'd be cutting the front, which is curved, you'd be cutting the back, which is curved, you would be cutting out this circle. Now I'm drawing it flat because that's what it looks like here, but it's going to be a circle. So we need the area of the circle, which means I need to know the radius of the circle, because the formula for the area of a circle is pi times r squared. So I need the radius of the circle, which we already found. We said it was 5 centimeters. So we could say the answer is 25 pi. There are no rounding directions for this one. So I could say that answer, or I could say about, if I round, 78.5. But we kind of didn't need to do this work because pi r squared is the area of the base. The area of this base will be the same as the area of that base, will be the same as the area at any cross section. That's the thing about oblique cylinders. It's just like if it's not oblique, any of those chunks will be the same, which is why the volume formula still works.